Hello everyone, this is Pranay. Today we will be seeing our Compiler Lab Experiment number 5, which is a simulation of a DFA. So in this uh, experiment, we will try to simulate a DFA. We have this algorithm, okay, which you might use this. So what we have to do is we have to give a sample input. The input will be a DFA transition table, and whatever string we are giving here, we have to check whether it is getting accepted or not. Okay. So I've created this Java program. In this Java program, I'm trying to create a transition table using a double two-dimensional array. Some array of non-terminals. I've declared all the variables here. First, what I'll try to create is initialize the DFA. Okay, and I'll just do a code for it. Okay, so we'll just try to run this code and check what happens. Okay, you'll understand it by then. It's just a simple code. If you look at it, you'll understand. Okay, so let me run it and go. Let me walk you through this process. I'll enter these DFA transitions. Okay, here the final state is, I guess, D1. So enter the number of non-terminals. So enter in this case, non-terminals will be A and B. So how many are there? There are 2. So I'm entering 2. Enter the non-terminals. So A, small a, and this small b are the non-terminals. Okay, enter the number of states. So how many states do we have? We have 4. So 4 states. So we don't have to mention the states because I have taken these states as not A, B, C, D, but as 0, 1, 2, 3. Okay, so here it is asking. So what it asks me here, transition should be within the given states. Okay, so enter transition of state 0 on terminal A. So 0 represents A represents 0, so 0 on small a becomes 1. So here's what it is 1. Okay, now since it is here A, which means 0. Okay, transition on 0 on B is 0. Okay, similarly we'll continue. So transition on 1 on small a is 1, 2. It's going in row order. Okay, then again 1, then 3, then 1 and 0. Okay, by this we have entered all the transition. So our DFA transition table is ready. And asking me how many final states are there. So at least there should be one final state. That's why I've written it should be greater than 0. So enter the number of final states. So it is at least 1 in this case. Okay, and enter the final state. So what are the final states here? So I'm going to mention it is the D. So D is 3. So 3 is the final state. Okay, let me see whether it works or not. Starting state would be A, so it is 0. Now enter the input string. So input string is AA BB. Okay, yeah, so this string is accepted. Okay, now if we go to the code right now, so I think you've understood how it goes through. So what happens is, let us go to the code. So main function, okay, access5, it will call that object dot initial DFA. I'll go to initial DFA. Now in initial DFA, what happens is, I've entered the number of terminals. I've taken it, enter the non-terminals in the for loop. In an array of non-terminals, I've entered all the non-terminals. Okay, I've also entered the oh, it should have been terminals, not non-terminals. The only thing I have used is the part. If I enter the number of terminals, this should be terminals, not non-terminals. This is simple mistake, but we'll continue. Here I'm using a for loop to enter all the states based on that. Okay, now I'll take in final states here, then final states into an array if it's more than 1 or 2. and I'm calling DFA test. In DFA test, what happens? It asks for the start state. It asks me for the input. I'll take the input string. I'll concatenate that with the hash symbol as an end operator. Okay, end of to represent end of string. Now I'll check for character at that index whether that character is there or not. And one by one, I'll check with the transition table. Okay, if it's there, then I'll go on continue. And if it reaches the final state, then I'll say okay, if the input is, and I'll set the flag. Okay, and if when it comes out of the loop, if flag is set to 1, then input string is accepted, or it is not accepted. Okay, this was our experiment number 5 in compiler. That was simulation of a DFA. Thank you for watching. Have a nice day.